In this session, we're going to add to our project a two-wheel, two-motor differential drive. First, we'll go to the class list. We're going to the FRC namespace. We'll come down and select DifferentialDrive here. Using the DifferentialDrive class, we can construct a drive system with a left and right motor. We'll be able to use methods called arcade drive, curvature drive, tank drive. We'll be able to use this method here to set a deadband. And when we construct the differential drive, for example, let's look at tank drive here. We can set our left and right speeds and whether or not we want the squared inputs. So we can use this to get rid of our squaring code, our exponential code that we had before. Use the deadband method to take care of the deadbands. So let's jump into this. Going to the H file here, we're going to declare first we have to get the header, which I've already put in right here. You'll notice that it differs from what's in the documentation. It does not have this right here, so it'll be frc/drive/differentialdrive.h. We're going to create the object in the FRC namespace. It will be of type differential drive. We will call it M robot drive, and it will initialize with these two objects here: left motor, right motor. So now we have the object that we wanted. We're going to save this. We're going to go to the CPP page now and go to where we had our earlier code. We're just going to what this construction here is basically is a tank drive. So we're going to go .t tank drive left y y right y, and we can get rid of this code. We can also put in an optional parameter here. It says true, and what this does is this takes care of the squared inputs. So setting that to true gets rid of all of this code. Using this drive object, we get rid of all of this. Let's take care of this stuff right here. And what we can do to do that, there's a couple of ways to do it. In the differential drive class, there's a max power function, which is a scaling function. I'm going to use something straight out of the standard C library. Which is called clamp. We're going to put in Y, and we're going to clamp it to minus 0.5 to 0.5. That will clamp that value, the left Y, and this will be the right Y. So the clamp code gets rid of all of this mess right here. And the robot drive class by itself automatically does a deadband of 0.02, I think it is. Of 0.02, we can confirm this. If we go back to our documentation and search on the deadband, you can see it's 0.02. Otherwise, we can change it with set deadband. set deadband here, and we're going to just make it 0.1 just for the fun of it. That will override the default of 0.2. So this code just got a bit simpler. Got a clamp, a deadband, and we drive it, and we're done with that. I have a bit of an error to correct here. You have to capture the value of it. So RIY is equal to this clamped value. So this will get clamped within this range, gets reassigned to left Y. This gets clamped in that range, gets reassigned to right Y. Then it passes on through. And just to verify that all this works, we can now build the code and deploy it. Moving to the driver station, we can enable it, take a look at the dashboard. This right Y is doing the correct thing. The left Y is way over here. Let's just move it down so we can see it more properly. Left Y, right Y, and that is correct. This is the really easy way to limit the values, set the deadband, and do your robot drive.